Hello everybody, today I will be showing you how to go about the second free response question in 2016's AP Calculus BC exam.
Problem number 2 is a very straightforward parametric motion problem where we're given that dx dt is given by that function and our y of t is given by this graph, and our initial starting position when t equals 0 is 5, 1. Part A asks us to find the position of the particle at time t equals 3. How we go about this is that we need to split the problem into two parts, the x component and the y component. In order to find x of 3, we need to use our initial condition, which is x of 0, and to that add the total change in x over the time period from 0 to 3, which is given by the integral from 0 to 3 of dx dt over dt. This can be simplified to x of 0 being 5, as is given, and this integral we can find using a calculator, since this is one of the ones where we can use a calculator. Waiting. And we get 9.377. So we add that together, and we get that our final x position is 14.377. Now for the y part, this is much simpler. Y of 3 is equal to, looking on our graph, y of 3 is equal to negative 1/2. Easy. So we get that our position of our particle when the time t equals 3 is 14.377 and negative 0.5. When you're doing the calculations, remember not to forget the 3 decimal places, otherwise you'll get dinged on the AP Calculus test. Part B asks us to find the slope of the line tangent to the path of the particle at t equals 3. So whenever we see the words slope of the line tangent, we know that we need to be using dy over dx. And in parametric, this can be rewritten as dy over dt over dx over dt. And we want to solve this for when time equals 3, or t equals 3. dy dt, we can find the slope of this line, and it is 1/2, which is fairly simple. And in order to find the derivative of the x portion, we just plug in 3 to this, which is 9.956, turns out to be 0.050. Part C of this question asks you to find the speed of the particle at time t equals 3. The speed is given as the square root of dy over dt squared plus dx over dt squared. And so what we do here is that we plug in dy dt and dx dt when t equals 3. So we already found these in part B. So what we do is we say that speed is the square root of dy dt squared, and dy dt when time equals 3 is 0.5. And we want to add to that, we want to add this 9.956 and square that and square root the whole thing, and using our calculators we get that this is 9.9685. Part D asks us to find the total distance traveled by the particle from time t equals 0 to t equals 3. In order to find the total distance traveled for a parametric particle, we need to integrate its speed. So we need to integrate its dy over dt squared plus dx over dt squared dt from 0 to 2. Now if we look at our graph, we notice that on the interval from 0 to 2, y of t isn't constant, so we need to break up this integral as into two integrals. Now that we have this, we can simply plug in the rates of change of y of t for each given interval. So on the interval from 0 to 1, the rate of change of y of t is -2, and on the interval from 1 to 2, the rate of change of y of t is 0. And from here on, we plug this ginormous thing into our calculator. We have dx dt stored as y1, and so that simplifies things a lot. We get that our answer is 4.349. And that's it for the entire problem. On this FRQ, it's fairly easy to get a lot of points just by setting up equations and not even plugging them into your calculator and answering them. Just by looking at the scoring guidelines, you could get a total of 5 out of 9 points just for setting up the equations and not even trying to solve them, which is fairly good given that you don't need too many points to get a 5 on the Calculus BC exam. For example, just writing this first line for part A would give you 2 points total for using this integral and using this initial condition. That's an example of how just even writing and setting up stuff on the AP exam can earn you a significant amount of points. If you found this problem fairly difficult, I have linked some practice problems that you can do, and in addition I have linked a Khan Academy video and another Canyon Crest Academy student explaining parametric equations. Thank you, that's all I have for you today.